So in example 2, we want to simplify just radical expressions, right? Like, for example, the square root of 12, square root of 48, square root of 72, the square root of 175. So there's a property regarding radicals that as long as you have the nth root, here our root is 2 because we say square root. If you have like the nth root of a, this could be equal to the nth root of b times the nth root of c, where essentially b and c, when you multiply them together, it gives you back a. So the idea here is that if you have, for example, the square root of 12, you want to think about, okay, what are two numbers when I multiply them that gives me 12, but at the same time, one of them must be a perfect square. So what are your factors of 12? Let's start with that. What are some factors of 12? Okay, wow, why is it so loud outside? Factors of 12 are going to be 1, 2, 3, 4, 6, 12. Now, look at your factors. Are any of your factors perfect squares? Yeah, which factors? 1, yeah, because 1 squared is 1. 2 is not a perfect square. 4 is a perfect square. 6 is not a perfect square. There's only 2 of them. You guys said it. 1, because 1's, right? So 1 is a perfect square because 1 squared is equal to 1. 4 is a perfect square because what number squared gives you 4? Will, what number squared gives you 4? 2. 2 squared gives you 4, right? So the square root of 12 can be broken down as the square root of 4 times some other square root number, right? So 4 times what gives you 12? 3. So you break this down as the square root of 4 and the square root of 3. So the square root of 4 we know is 2. The square root of 3, however, cannot be broken down any further because 3 is not a perfect square. Okay. Remember, perfect squares, right? Some little notes here. Some common perfect squares that you should be familiar with are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. These are some common ones that you should know, right? For example, the 121, we get that from doing 11 squared, right? 11 squared is 121. All right? So you want to look for one of these factors. When you factor one of these numbers, you look for basically any perfect squares, namely the highest one. Let's look at 48, trying to simplify the square root of 48. Think about all the factors of 48. We can list them. What are some factors of 48? Well, 1, 2, 4 works. 8. 8 times what gives us 48? 6. So 4, 6, 8. 4 times what gives us 48? Yeah, multiply by 12. All right, we said 2. 2 times what gives us 48? 24. 1 times what gives us 48? 48. So you're actually missing 2 factors. You're actually missing 2. Do anybody know what 2 factors they're missing? There are 2 other numbers that when you multiply them, it still gives you 48. Huh? I have it. 2 times 24. That works. Anybody? No? 3 and 16 works. All right. So when you look at your factors of 48 now, what is your highest perfect square? The biggest one that's there. 24 is not a perfect square. 16. 16 is the biggest one. 16 is. So the square root of 48 can be broken down as the square root of 16 times the square root of 3. Square root of 16 is 4. So this is going to be 4 square root 3. How's it going, man? All right, let's look at the next example. Square root of 72. What you would like to do is think of all your factors of 72, right? So we can list them. What are some factors of 72? 1, 2, 4. Okay, well, let's try to figure out, let's write it as pairs. We can do it that way. 1 times what gives me 72? Say it louder. 72. Now, 2 times what gives me 72? 36. Okay. You also said 4 worked. 4 times what gave me 72? I'll give you the answer. I'll say 8. I'll give it to you. It's 18. 4 times 18 gives you 72. There's more factors. You're missing a few more. 6. 6 times what gives us 72? 6 times 16, yes. What else? 8 times 9. Okay, that works. We're missing a couple more. I think we're just missing 1. You're missing 3 again. 3 times 24. All right. I'm just gonna stop there for now. If you notice, factors of 72 have a lot of perfect squares. You have 1, you have 4, you have 9, you have 16, you have 36. The good thing is that you always want to use the highest one. So what is the highest perfect square? 36. So square root of 22 can be broken down as the square root of 36 times the square root of, well, 36 times what gives us 72? Times 2. There you go. Now the square root of 36 is 6. So it's 6 times square root of 2. All right, let's look at one more example, and then we could move on to another example or another problem. We have the square root of 175. So what are some factors of 175? Or just looking at that number, what's one number that you know automatically goes into 175? Not 10, but 5, right? Because 5 can go into any number that ends with 0 or 5. Now, 5 times what is 175? I'll give you a hint. First, start off with 100. 5 times what gives you 100? 20. 5 times 20 is going to be 100. Now, 5 times what will give us the remaining piece? The remaining piece is 75. So 5 times what gives us 75? Say again? 35. Well, 5 times 35 is the answer. Yes. So the factors of 175, other than 1 and itself, is going to be 5 and 35. But there's another factor that I'm more interested in with. Think about money, for example. 25. There you go. 25 definitely works. If you think about it as $1.75, right? Think about it as a $1.75. Then you can definitely represent this with quarters, right? With 25. 25, if you think about 25 cents or 25 cents, how many quarters is $1.75? 7. There you go. So if you look at your factors of 75 here, one of them is a perfect square. That is the 25. So square root of 175 can be broken down as square root of 25 times the square root of 7. Square root of 25 is 5. So you get 5 square root of 7. Okay? Alrighty.